All right, buckle up, everyone. Today, we're plunging headfirst into something that has absolutely dominated the AI conversation, OpenAI's GPT-5.
Yeah, the buzz was huge.
The buzz leading up to this release wasn't just immense. It was practically a roar, with whispers and comparisons to, well, monumental projects of human history.
Yeah.
For anyone following AI, this was the moment.
And that roar, for us, that's kind of the signal to cut through the noise, right? Our mission today is really to unpack the core capabilities of GPT-5. We want to understand its architectural shifts, analyze its actual real-world performance, against the benchmarks and user expectations, and truly explore the broader trajectory it suggests for large language models.
And we'll get into the technical challenges, too, the ones that still linger.
Definitely. And even some alternative approaches within the AI landscape that maybe don't get as much airtime in those big official announcements.
Absolutely. To do that, we've stacked up a really diverse set of sources for this deep dive. Everything from OpenAI's own official announcements to meticulous deep dive analyses from leading AI researchers, comprehensive industry reports.
And critically, that direct user feedback from online communities like Reddit and X, formerly Twitter, you need that ground truth.
You really do. It's this multifaceted, deeply technical perspective that lets us really get at what's actually happening under the hood.
Mm-hmm.
And as always, for more insights and the latest AI and ML research papers, you can always visit our webpage, neuralintel.org. Okay, let's peel back the layers on this one.
Yeah.
So the curtain dropped for GPT-5 during a live stream event on Thursday, August 7, 2025. There was so much anticipation you could almost feel it in the air.
Yeah, the buildup was intense.
And Sam Altman himself, he painted this picture of GPT-5's abilities as being on par with a PhD-level expert across various fields. Now, that's a pretty bold claim.
It's a very bold claim, especially given the history, right? The sky-high expectations he set for AI progress, even going so far as to previously compare efforts to a Manhattan Project.
Right.
What's truly fascinating here, I think, if you look beyond the marketing spin, is this inherent tension. You've got the grand narrative, the one about achieving artificial general intelligence, AGI, which, let's be honest, has been incredibly effective for fundraising.
Undeniably.
But then you have the practical commercial reality of releasing a widespread consumer product. And these two things, they often clash.
So the hype sets it up for disappointment almost.
It often sets up a situation where even extraordinary technical achievements can be perceived as under-delivery, simply because they don't quite meet that revolutionary, almost science fiction level standard that the hype suggests.
Yeah.
It shifts the whole conversation, from celebrating brilliant engineering to debating philosophical implications, which is just a very different beast altogether.
And you saw that tension manifest immediately in the initial user reactions. It was a complete mixed bag, almost like a tale of two different products.
Polarizing.
Definitely.
Yeah.
On one side, there was this swift and pretty vocal backlash,
Right.
especially from many longtime ChatGPT users. They vented their frustration loudly across social media, Reddit, X, you name it.
And the core issue seemed to be that model picker.
Exactly. The core issue, and this is a significant technical and user experience decision, was the removal of the model picker. That little drop-down menu that lets you choose between models, gone.
Cool.
This forced users onto GPT-5, essentially removing their direct access to previously favored models like GPT-4o, 03, and even a 4 Mini.
Now, this decision by OpenAI really sparks a debate, doesn't it, about control versus optimization.
For sure.
While the stated intent was to provide a seamless, unified system that intelligently routes queries, for many users, it just felt like a profound loss of agency. Like, hey, I knew how to use that tool.
And the complaints were quite stark. Users reported that ChatGPT felt completely ruined.
Strong words.
Very. They cited slower performance, even when the system wasn't in its explicit thinking mode. Shorter replies, what they saw as basic errors, a consistent failure to follow instructions.
And the general loss of the model's former personality or vibe, people get attached to that.
They really do. One user's lament, and this quote stuck with me, "I really feel like I just watched a close friend die." It might sound dramatic.
A bit, yeah.
But it captures the deep emotional investment some power users had in the previous iterations. It just highlights how deeply integrated these tools have become into their daily workflows.
It really does. And then the accusations started.
Oh yeah, they start flying fast. Many users speculated that OpenAI did everything in their power to shorten the answers to be as specific and targeted to save money.
Oof. That's a direct challenge to the business model, suggesting, perceived utility was sacrificed for cost efficiency.
From a technical perspective, if that's true, It points to maybe a fine-tuning or deployment strategy that prioritizes token efficiency over, say, verbose or creative output.
It's a trade-off. It's always a trade-off at scale. One that might boost the provider's bottom line, but certainly frustrated those power users who depend on longer, more nuanced responses. It makes you wonder how that internal balance is struck.
It's a tough balance for any company operating at this scale, no doubt.
But to provide a truly balanced technical assessment, we absolutely have to look at the positive assessments too, because they were definitely there.
Right, it wasn't all negative.
Not at all. Other users and early testers reported vastly different experiences. Some found GPT-5 to be a sleeper model, like quietly performing exceptionally well.
Interesting.
They reported it was almost on par with Opus for coding. And just to clarify for listeners, Opus is Anthropic's top-tier Claude 3 model, widely seen as a leader in code generation. So that's high praise.
That is high praise.
Others hailed GPT-5 as a monumental improvement for tasks like document comprehension, noting it felt smarter and faster for general tasks, trip planning, image generation, even songwriting.
So this stark contrast, it suggests that maybe the unified routing system, while aiming for seamlessness, might have just delivered wildly different results depending on the user's specific workflow or the type of query.
That seems plausible, yeah. The router might not be perfectly tuned for every edge case yet.
So what does this all boil down to? One very compelling viewpoint that emerged was that while AI insiders, maybe people like us, might have been disappointed by a lack of a revolutionary AGI leap.
Which, frankly, was never really on the cards for this release.
Right. But the 99% of people using ChatGPT are going to be so happy about the upgrade.
The democratization argument.
Exactly. The logic here is that free users, by default, gained access to a model comparable to or even better than previous high-tier models, all without having to navigate model selection.
Which broadens access to advanced AI capabilities significantly. It's a major step, even if it ruffled the feathers of power users accustomed to more granular control and specific model behaviors.
This really highlights a persistent technical and UX challenge in large-scale AI deployment, doesn't it? How do you balance the needs of those sophisticated power users who really understand and leverage nuanced model differences?
With the desire to simplify and optimize the experience for a vast general user base, it's a classic product dilemma.
Yeah. The decision to remove the model picker, while causing friction for some, was clearly aimed at the latter, providing a streamlined, automated experience.
And the technical success of such a system relies entirely on its router being exceptionally accurate in discerning user intent, which is easier said than done.
And that brings us neatly to another area that came under scrutiny: marketing and transparency.
Ah, yes, the charts.
Speaking of transparency, there was a pretty notable controversy surrounding some misleading charts presented during OpenAI's livestream event.
Yeah, that wasn't great.
One particular example that caught a lot of attention was a coding deception chart. GPT-5 ostensibly had a higher deception rate than the O3 model, yet it was visually represented with a smaller bar on the chart.
Which incorrectly implied better performance, a visual inversion of the data.
Exactly.
This is just a critical misstep in technical communication. In quantitative analysis, how you visualize data is paramount. It has to be accurate.
Of course.
Here, the chart visually inverted the meaning of the data, showing a smaller bar for a higher deception rate. That's not just counterintuitive, it's fundamentally misleading.
And Altman admitted it, right?
He did. Sam Altman himself openly admitted it was a mega chart screw-up, and a subsequent correction in blog posts clarified that GPT-5's actual deception rate was much lower, at 16.5%.
Okay, so the real number was better, but the initial presentation was botched.
Right. But the implication of errors like that on trust in AI progress and the veracity of reported benchmarks, it's substantial. It just underscores the absolute need for meticulous rigor, not just in the models themselves, but in how their performance data is presented to the public, especially in a field where complex metrics can be so easily misinterpreted.
Transparency is key, especially when expectations are so high. Okay, let's dig into GPT-5's core technical identity now, because this is where a lot of the magic and maybe some of the friction comes from.
Yeah, the architecture.
The biggest architectural shift isn't that GPT-5 is just one single monolithic super-duper model. Instead, it's presented as a unified system. And this fundamentally alters the user experience by replacing that previous manual model selection, which we talked about, with a seamless automated process.
And what's truly ingenious here, I think, and really the core innovation, is the real-time router at the heart of this unified system.
Router, right.
Think of it as an incredibly intelligent air traffic controller for your queries. It's an orchestration layer that rapidly decides which model to engage for a particular query, supposedly in milliseconds.
Wow, milliseconds.
This dynamic selection mechanism is designed to optimize for both efficiency and performance simultaneously. It considers several criteria. The conversation type is it creative, factual, the complexity of the query, the need for specific tools.
And even explicit intent, like if you actually tell it, hey, I need you to really think hard about this.
Exactly, that explicit signal matter.
So it's not just a simple if-then statement like, if complexity X, use model Y. It's more dynamic. It's a continuously learning adaptive system. That sounds like quite a leap.
That's the claim. The router isn't static. It's described as being continuously trained on real signals.
What kind of signals?
Things like capturing data points from when users manually switched models in previous versions, or what their preference rates were for different responses, and, of course, measured correctness on various tasks.
So it's using past behavior to predict future needs.
Precisely. This implies a sophisticated, adaptive feedback loop designed to improve routing accuracy over time, making the system more efficient and better aligned with actual user needs.
Okay, but here's the core technical challenge then, right? How does this router efficiently and accurately classify user intent and query complexity in real time at massive scale to pick the optimal model without adding significant computational overhead or, worse, making mistakes?
That's the million-dollar question.
And what are the underlying mechanisms that allow for this real-time aspect across such a diverse user base and query landscape? These are the kinds of questions that demand a deeper look beyond the high-level descriptions OpenAI provides.
Absolutely. It's a fascinating technical problem to solve, building this complex, low-latency decision-making layer that operates almost invisibly to you, the end user.
Diving deeper into the internal model hierarchy within this unified system, we know there are distinct components working behind the scenes.
Right, it's not monolithic.
First, there's what OpenAI calls a smart and fast model. This is designed for most general questions, aiming for quick, efficient responses, your everyday queries.
Workhorse model.
Then, for more complex problems, there's a deeper reasoning model, often referred to as GPT-5 thinking.
And for the most demanding tasks, they mention an exclusive GPT-5 Pro model.
So this tiered internal structure, managed by that router, theoretically allows OpenAI to deliver a range of capabilities efficiently.
In theory, yes. But it also helps explain some of that initial user friction we discussed earlier.
How so?
Well, for instance, if your prompt was implicitly complex, but the router, for whatever reason, maybe it misclassified it, sent it to the smart and fast model, you might experience a perceived downgrade in quality or depth.
Ah, okay. You'd feel shortchanged.
Exactly. Conversely, if a simple query got routed to the thinking model, it might feel unnecessarily slow, even if the underlying reasoning was more robust than needed.
So the technical elegance of the router is therefore directly tied to its ability to make these routing decisions flawlessly and at scale. It has to minimize those user-perceived performance variations.
It's a true orchestration challenge. Getting that balance right consistently is incredibly difficult.
And this unified system, along with its sophisticated routing, it isn't just for consumer ChatGPT users, is it? Microsoft is heavily involved.
Oh, yeah. Microsoft, as one of OpenAI's biggest partners, is heavily leveraging this architecture within its own massive ecosystem. Think about products like Microsoft 365 Copilot and Microsoft Copilot.
All right, they're everywhere now.
In those tools, users automatically get the benefit of powerful new AI reasoning capabilities without ever having to think about which model is best for the job.
Because Microsoft has its own router.
Essentially, yes. Microsoft's own built-in model router residing within their Azure AI Foundry orchestrates the deployment of these GPT-5 capabilities.
So it sits on top,
Well, yeah.
directing traffic.
Precisely. This means that a complex query in Microsoft 365 Copilot, say, analyzing a dense financial report gets routed to the appropriate deeper reasoning model within the GPT-5 system, while a simple request for a creative email draft might go to the smart and fast model.
That makes sense.
It highlights how this modular router-driven design enables large-scale, incredibly efficient integration into diverse business workflows. It abstracts away the underlying model complexity from the end user in a very practical, seamless way.
It's a testament to the engineering effort involved, making these advanced models consumable within existing complex software stacks. All right, now that we understand a bit more about how GPT-5 is structured internally, let's talk about what it can actually do. Performance.
The fun part.
OpenAI has made some pretty bold claims regarding enhanced reasoning and a significant reduction in hallucinations. They're reporting reductions of approximately 45% compared to GPT-4o,
Which was already pretty good.
and up to a remarkable 65% reduction in hallucinations compared to the prior O3 model.
Those are truly substantial figures. And if we connect this to the bigger picture of AI reliability, it's a critical advancement, especially for any kind of high-stakes application.
Absolutely. Imagine the difference this makes for someone trying to get reliable info for a critical report, or even exploring health questions.
The technical mechanisms behind this claimed improvement seem multifaceted. OpenAI describes an improved reasoning engine that apparently weighs more potential answers in parallel before responding.
So it's thinking more broadly before answering.
It suggests a more robust internal deliberation process, yeah. Moving beyond just the single linear path of token generation, almost like it's trying out different thought processes simultaneously.
Interesting.
Couple that with expanded contextual awareness due to its large context window, which can be up to 400K tokens in the API.
That's a lot of context.
It is, and it means the model is significantly less likely to contradict itself or invent information just because it forgot something from earlier in the conversation or document. It's a huge step towards internal consistency, which has been a persistent challenge for LLMs.
So if it's weighing multiple answers and has this massive memory, does that mean we can actually trust it now for more critical applications? Or are there still inherent limitations we need to be aware of?
That's the million-dollar question, isn't it? While a 45% reduction is phenomenal, it doesn't mean zero hallucinations.
Right, still not perfect.
Not perfect, but it means, maybe for the first time, we're seeing a model reliable enough for critical first drafts in areas like legal document analysis or even medical information gathering, where before you'd frankly spend more time fact-checking than creating. That's a fundamental shift in utility.
It is a big shift.
Furthermore, the safe completions framework is another key technical component here. This isn't just about refusing harmful content. It actually tries to provide helpful responses within defined safety boundaries and transparently explains why it might refuse a complete answer, rather than just shutting down with a generic refusal.
More transparency is good.
It is. This refined approach to safety, combined with better training data filtering and reinforcement learning, focused specifically on factual correctness, aims to produce more reliable and trustworthy outputs overall.
And they mentioned agentic decision-making.
Yeah, via chain of thought reasoning, essentially enabling the model to think through its logic internally to catch logical errors before the output is generated. The ability to structure its own thought process to preemptively identify and correct errors, that's a vital step towards more dependable AI systems.
That deep reasoning sounds crucial for real-world reliability. But let's talk coding, because GPT-5 is being touted as a smarter coding partner and even a full-on transformation for developers.
The coding claims are significant.
The focus seems to be on something called agentic coding. What does that actually mean in practice?
Yeah, agentic coding basically means it's more autonomous, more collaborative, and far better at reasoning through complex tasks than previous models.
So beyond just suggesting the next line of code.
Way beyond. This is a profound shift from simple code completion or snippet generation. For instance, it can now provide comprehensive project structures, suggest appropriate frameworks like React or Node.js, auto-generate entire modules, and even create foundational documentation for complex applications like a full budgeting app. It's essentially acting as maybe a junior architect or even a lead for simpler projects. And what's truly impressive here technically is the real tool integration through free-form function calling.
Free-form function calling.
Yeah, this allows it to pass raw SQL queries, shell commands, or config files directly to tools without the rigid JSON formatting older models required.
Oh, that's huge. No more wrestling with JSON structures.
Exactly. It's like it speaks the language of the tool natively. It dramatically simplifies API integration and enables more natural, efficient interaction with external systems. It's a massive leap for automation and development workflows.
So it's not just generating code, it's understanding how that code interacts with other systems and tools, and it can adapt its output to those interfaces. That ability to interact seamlessly with tools is a game changer for developer workflows.
Absolutely. And its debugging and repository analysis capabilities are equally impressive, apparently, with its substantial 256K token context window.
Which is still huge, even if not the full 400K.
still massive. To give you a sense of scale, that's like 200,000 words, roughly a novel's worth of code. It can ingest and understand huge code bases, spot bugs across multiple files, and suggest line-by-line fixes with detailed explanations.
So it gives you the why, too.
Exactly. This truly makes it less like autocomplete and more like a senior engineer, providing not just solutions, but also the reasoning behind them, which is invaluable for learning and trust.
And front end. It can design interfaces.
Apparently, yeah. Its front-end finesse means it can design clean, functional interfaces in popular frameworks like React or Tailwind, even without explicit design guidance. OpenAI claims it has an inherent aesthetic sense for polished modern designs.
Wow, the idea of an aesthetic sense in code design, that's something I hadn't really considered before. How do you even train a model to have good taste?
Well, it's probably less about taste as we understand it and more about extremely sophisticated pattern recognition from vast amounts of high-quality modern design code it was trained on. But you're right about the implication.
This sounds like it's democratizing software creation in a really serious way, almost enabling what you might call vibe coding.
It definitely lowers the barrier to entry. It can generate fully realized apps and software in minutes from just natural language prompts, opening up software creation to non-coders, or at least non-expert coders.
Like that French learning game demo.
Exactly. Imagine describing a simple French learning game you want and having a functional, playable version generated almost instantly. That ability democratizes initial prototyping and even simple application development significantly.
And the benchmarks back this up.
They seem to. On the benchmark front, to validate these claims, it's leading, scoring 74.9% on SWE Bench Verified and 88% on Aider Polyglot with reasoning enabled. These are academic benchmarks specifically designed to test a model's ability to autonomously fix bugs and perform code generation. So its strong performance there does back up that smarter coding partner claim.
Okay, beyond coding, GPT-5 also shows marked improvements in specialized domains like writing and, interestingly, health-related queries.
Yeah, the writing improvements focus on handling structural ambiguity better and producing compelling, less AI-sounding creative texts.
Getting away from that robotic feel.
Hopefully. It entails a more sophisticated understanding of narrative structure, character voice, stylistic nuances, moving away from the generic, often formulaic text we saw in earlier models. It's subtle, but potentially very important for creative professionals.
And health. That sounds sensitive.
It is, and OpenAI is careful with the framing. It's described as the best ever model for health-related guidance, acting as an active thought partner.
What does that mean, thought partner?
It means it can apparently flag potential issues in information you provide, ask clarifying follow-up questions, help you interpret test results you upload, explore treatment options based on medical literature, and even help prepare you for doctor appointments.
So organizing information and questions.
Right, and it adapts to the user's knowledge level and location, aligning with regional standards. However, and this is crucial, they reiterate it constantly. It does not provide medical advice and is not a substitute for professional care.
Absolutely. Critical distinction.
It's a tool for information and preparation, not diagnosis or treatment. It's about empowering you to have better, more informed conversations with your actual doctor, not replacing them.
Got it. Finally, let's touch on speed and this dynamic answers feature. Sam Altman described the increased speed as psychologically disorienting. That's a powerful phrase.
It implies near instantaneous complex thought, doesn't it? A model that really keeps up with your brain. But the dynamic answers feature is particularly intriguing from a technical standpoint.
How so?
Unlike previous models that often tried to give the one perfect answer, GPT-5 apparently won't always give the exact same answer to the exact same question. Instead, it explores multiple valid interpretations.
So it's less deterministic.
Exactly. This shifts the user's prompting mindset away from crafting that single perfect question towards engaging in a more conversational, iterative, and exploratory dialogue. Ask, refine, ask again.
That flexibility sounds great for creative tasks, brainstorming.
For sure. However, it raises an important question for technical users. What are the implications of this non-determinism for precise technical tasks, like generating specific code snippets or mathematical solutions where a consistent, reproducible output is often absolutely paramount?
Right, if the answer varies even slightly each time.
How do developers ensure reliability and correctness in automated workflows or critical applications? This non-deterministic behavior, while potentially beneficial for open-ended creative tasks, could introduce real complexity in areas requiring strict logical consistency and auditability. It's a trade-off.
That's a really important point about precision versus flexibility. Okay, let's just focus now to the market strategy behind GPT-5, particularly its pricing.
The economics. Always key.
OpenAI has priced GPT-5 at 1.25 per million input tokens and $10 per million for output. That's a pretty significant drop, isn't it? Especially given it's half the input cost of GPT-4o.
It's aggressive. This pricing strategy is a clear move to solidify OpenAI's market dominance and drive significant adoption. No question about it.
And it puts it right up against Google.
Directly. The pricing for smaller inputs even matches Google's Gemini 2.5 Pro, indicating a direct head-to-head competitive maneuver. They're not messing around.
And they have cheaper variants, too.
Yep. What's more, they've introduced mini and nano variants for even greater cost effectiveness. We're talking 0.25 per million input for mini and a mere 0.05 per million for nano.
Wow, 5 cents.
This modular pricing allows developers to select models optimized for specific cost-performance trade-offs, encouraging broader integration into all sorts of applications, from simple chatbots to more complex agentic systems. It's basically an open invitation to build on their platform.
And the token caching discount. That seems like a smart technical detail, offering 90% off on input tokens that have been used within the previous few minutes. That feels like a direct response to how people actually use these models in chat.
It is, absolutely. That's a highly efficient technical optimization, especially for chat-based UIs.
Makes sense.
It dramatically reduces the cost of multi-turn conversations and revisions, as repeated context doesn't incur the full cost each time. This directly encourages longer, more iterative interactions within the chatbot interface, which aligns perfectly with that dynamic answers approach we just discussed. You're encouraged to explore and refine.
And it saves OpenAI compute too, presumably.
From a technical infrastructure standpoint, yes. It means more efficient utilization of compute resources by avoiding redundant processing of already seen tokens, passing those savings directly to you, the user or developer. It's a clever way to make the economics work for sustained, complex interactions.
Okay, however, despite the aggressive pricing and broad rollout, the tiered access and usage limits, they have created some user friction, haven't they? Especially for power users.
Yeah, the tier system is causing some grumbling.
GPT-5 is rolling out across free, plus, pro, and team tiers. But the experience varies quite a bit depending on your subscription level.
Right.
Free users get capped access to the base GPT-5 model, then are automatically downgraded to a less capable GPT-5 mini model after hitting their limits, which is understandable, maybe.
Standard freemium model stuff. But it gets tricky with the paid tiers.
Exactly. Plus, users get significantly higher usage limits than free users, and the ability to manually select the GPT-5 thinking model. But even that is capped at 200 messages per week.
And that 200 cap seems to be a real sticking point.
It has led to genuine complaints online, with users feeling that 200 per week for the thinking model kind of sucks, or that they're being double-dipped on the cap limit during revisions because the bot's own responses kind of gets their strike limit.
Ouch. That feels a bit unfair if the bot is verbose.
Right. Pro and team users, on the other hand, get unlimited access to the standard GPT-5 and exclusive access to GPT-5 Pro.
So this tiered access creates very distinct technical experiences, and the perceived value of the Plus tier in particular has become a real point of contention for power users who feel their workflow is being constrained by that thinking cap.
It's OpenAI balancing resource allocation again.
It is. The technical challenge for OpenAI here is managing resource allocation efficiently across these diverse user segments while maintaining a perception of consistent fair value. It's a tricky balancing act.
Okay, zooming out again to the broader AI arms race, which is always intense. How does GPT-5 stack up against its key rivals? Google's Gemini 2.5 Pro, Anthropic's Claude 3.5 Sonnet. Where does it sit in that competitive landscape right now?
Well, on the benchmarks, GPT-5 has certainly swept the Elm arena and is currently sitting at the top of the artificial analysis leaderboards. So purely on those metrics, it demonstrates state-of-the-art performance, unequivocally.
So it's the best, full stop.
According to those benchmarks, yes. However, there's a prevailing sentiment, I think, within the AI research community that the difference between OpenAI's models and the rest of the leading pack, Google, Anthropic, is actually pretty small now.
The gap is closing.
It seems to be. This implies an evolutionary rather than a revolutionary leap with GPT-5. It suggests that while OpenAI is maintaining its lead, the gap with competitors is narrowing. The industry is progressing in smaller, more frequent increments rather than these huge, sudden breakthroughs we saw maybe a year or two ago.
Which is maybe healthier competition.
Arguably, yeah. And if you connect this to the bigger picture of architectural design, this intense competition is driving innovation not just towards raw performance, but also towards practical considerations like cost efficiency and seamless system integration, which, at the end of the day, is great for you, the user or developer.
That makes sense. What about context window sizes? That's always been a big differentiator, a key technical metric for processing long documents and complex conversations.
That's a key area where we still see some notable differences. GPT-5 boasts a 400K token context window via the API.
Which is what, like 300 pages of text?
Roughly, yeah. Or hundreds of thousands of words. It's substantial for most applications. However, Google Gemini 1.5 Pro still holds the lead there with its massive 1 million token context window.
1 million tokens, that's huge.
It's enormous, roughly 750 pages worth. So while GPT-5's 400K is certainly impressive and very usable, that 1M token window in Gemini 1.5 Pro is still superior for sheer memory capacity.
So better for really, really long stuff.
Potentially, yeah, particularly for very large data sets, lengthy legal documents, maybe analyzing entire books in one go. This implies different optimal use cases for each model. Gemini 1.5 Pro might be better suited for those extreme long context applications where massive memory capacity is the primary requirement. Think in-depth research or legal e-discovery.
And this also raises questions about Google's future moves, doesn't it?
It does. They might lean even more heavily into multimodality, leveraging their infrastructure advantage to process not just text, but also video and audio at unprecedented scales within that massive context window. It's a different strategic path.
As we broaden our scope now to the overall AI landscape, let's dig into some fundamental challenges and emerging alternative paradigms. Things the official papers and announcements don't always highlight enough.
With stuff under the surface.
Exactly. One such challenge is position bias in large language models. Can you unpack that a bit?
Sure. Position bias refers to this tendency LLMs have to overemphasize information found at the very beginning and the very end of a document or of a long conversation.
While often neglecting the middle, kind of like how humans sometimes skim?
A bit like that, yeah. It's a subtle yet pervasive technical bias, and its practical impact can be surprisingly significant.
Give us an example.
Okay, imagine you're a lawyer using an LLM assistant to search for a specific, crucial phrase buried deep within page 15 of a 30-page affidavit.
Right in the middle.
Exactly. If that phrase is stuck right there in the middle, the LLM is demonstrably less likely to find it accurately compared to if it were, say, in the first paragraph or the concluding remarks.
That's not a minor flaw, then. That could lead to critical omissions in complex information retrieval tasks.
Absolutely. MIT researchers have delved into the root causes, and it seems to stem largely from fundamental transformer design choices themselves.
So it's not just a bug, it's practically baked into the architecture itself. That's genuinely fascinating, but also a bit concerning for long-form understanding.
Exactly right. Certain attention masking techniques, particularly what are called causal masks, inherently introduce this bias towards the beginning of an input sequence.
Why do they use causal masks, then?
Well, think of it like this. A causal mask is like a blindfold that only lets the AI see the words it's already read or generated, not what's coming next. That's absolutely crucial for generating text word by word, coherently.
Okay. For generation, not understanding.
Right. But when the model is trying to understand a long pre-existing document, this inherent bias towards the beginning is amplified with each additional attention layer in the model. So the deeper the model, potentially the worse the bias.
Which is problematic for tasks that aren't purely natural language generation, like that legal search example. Precise information retrieval, where all parts of a document should ideally be equally important.
Precisely. Now, there are things like positional encodings, mechanisms that help link words to nearby words, and they can mitigate position bias to some extent, but their effect can apparently be diluted in models with more attention layers.
So it's hard to fully counteract.
It seems so. And furthermore, the training data itself also contributes to this bias. If the training data implicitly favors information at the start or end of sequences, maybe summaries are always at the beginning, the model will learn and perpetuate that bias. It becomes a self-reinforcing problem.
This raises a crucial question for GPT-5 then, doesn't it? Especially with its impressive 400K token context window. While GPT-5 has demonstrably improved reasoning, Could this underlying architectural bias still impact its performance on very long, complex documents or extended multi-turn conversations? Especially given some of those user reports we mentioned earlier about GPT-5 seemingly forgetting earlier prompts in thinking mode.
That's a critical point. This is an area for ongoing technical scrutiny that really goes beyond just looking at impressive benchmark scores. The sheer size of the context window doesn't inherently eliminate this fundamental bias in how attention might be distributed.
You've hit on a really important nuance there. The ability to ingest a lot of data doesn't necessarily mean uniform attention to all that data.
Exactly. It's a deep, complex technical challenge the industry is still very much grappling with. It's a great example of what those internal researchers are probably thinking about constantly when they look at these models' limitations.
And this actually brings us to a really compelling counter-narrative to the prevailing LLM-centric paradigm, which is the fascinating rise of small language models, or SLMs, particularly in agentic AI. Ah, yes, the SLM argument. There's a provocative argument from an NVIDIA Research ArgSIF paper stating that small language models, SLMs, are the future of agentic AI.
Bold claim.
It directly challenges the common assumption that larger is always inherently better, especially when you're building specialized AI agents.
It is a bold claim, especially coming right after a major LLM launch like GPT-5, which seems to reinforce the idea of a powerful, large, unified system. So why are SLMs being positioned as potentially superior for agents? It sounds counterintuitive at first glance.
It does, was the argument.
It's multifaceted and honestly quite compelling when you dig in. First, SLMs are increasingly sufficiently powerful.
Really? Powerful enough?
Modern SLMs, models like Phi-2 Nematron H, Small M2, Himba, DeepSeek R1 Distill, Salesforce XLM28B, they're achieving comparable performance to much larger LMs. We're talking models in the 30 to 70 billion parameter range.
Okay.
And they're doing this in areas critical for agents: common sense reasoning, tool calling, code generation following complex instructions. But crucially, they do this with significantly higher efficiency.
How much more efficient?
Like potentially 15 times faster, achieving a 3.5 times higher token throughput in some tests. And their reasoning capabilities can also be enhanced at inference time with clever techniques like self-consistency or using verifier feedback loops, allowing them to rival larger models on complex tasks like math problems without needing the huge parameter count.
So the argument is that for many agentic tasks, sheer parameter count isn't the binding constraint anymore. It's more about optimized design and deployment.
That's a big part of it. It's not necessarily about replacing LLMs entirely, but recognizing that SLMs are becoming technically capable for a large subset of tasks without that massive computational overhead.
Okay, what's the second point?
Second, SLMs are argued to be inherently more operationally suitable. Their flexibility and specialization mean they're far more affordable and practical to train, adapt, and deploy as multiple specialized SLMs for different agentic routines.
Like a specialized tool belt, rather than one giant universal wrench.
Exactly. That's a great analogy. This allows for rapid iteration and adaptation to evolving user needs and changing regulatory environments. You can swap out or update a small specialist model much more easily.
And agents often don't need the full breadth of an LLM anyway.
That's another key point. Agentic applications often restrict LLMs to a limited subset of LM capabilities. So, a fine-tuned SLM is argued to suffice for these often repetitive, scoped, and non-conversational subtasks. Why pay for the whole orchestra when you just need the violin section for this specific piece?
Makes sense.
Furthermore, SLMs can achieve behavioral alignment more effectively, particularly with output formatting. If you train an SLM specifically to output JSON or XML, it's less prone to those frustrating hallucinatory formatting mistakes that general-purpose LLMs might make when faced with strict formatting requirements.
Reliability and structured output. That's a key technical advantage for predictable agent behavior in critical applications.
Absolutely. And this leads naturally to the idea of heterogeneous systems where different models collaborate.
Like a team of specialists, as you said, an LLM as the manager, maybe.
Yes, that's exactly the concept. The NVIDIA paper argues that incorporating multiple models of varying sizes, maybe an LLM for the root agency, handling the big picture decision-making, and then SLMs for subordinate tasks, handling specific executions is a natural and incredibly efficient approach.
How would that work in practice?
Figure 1 in the source material illustrates this well. It shows examples like a primary LLM orchestrating calls to specialized SLMs for distinct functions, or maybe a dedicated controller agent leveraging several SLMs for different subtasks within a larger agentic system. This modularity allows for a far more efficient allocation of compute resources.
And the data from agents helps improve the SLMs.
Right. Finally, agentic interactions provide a natural source of high-quality specialized data for fine-tuning expert SLMs, enabling continuous improvement in a nice, tight feedback loop. This practical mechanism further enhances the operational suitability and iterative improvement of SLMs.
Okay, powerful enough, operationally suitable. What about the cost? From an economic perspective, how do SLMs compare to their larger siblings? Because ultimately, cost drives adoption.
They are necessarily more economical, according to the paper. Serving a 7 billion parameter SLM is estimated to be 1030x cheaper in terms of latency, energy consumption, and FLOPs, that's floating point operations per second, a measure of processing power, than serving a large 175 billion parameter LLM.
10 to 30 times cheaper, that's huge.
It is. This enables real-time agentic response. Just prohibitive.
And fine-tuning is cheaper too.
Massively. Their fine-tuning agility is a huge economic advantage. Using parameter-efficient fine-tuning, or PVA techniques like LoRa, low-rank adaptation, means specializing in SLM requires only a few GPU hours, not potentially weeks, and huge clusters like full LLM training.
So you can adapt them quickly and cheaply.
Exactly. This allows for rapid adaptation and deployment without massive upfront investment. Plus, they support edge deployment.
Meaning running locally.
Yeah, they can be executed locally on consumer-grade GPUs. Think your gaming PC offering real-time, offline, agentic inference with lower latency and stronger data control. You don't have to send data to the cloud. This decentralization dramatically reduces reliance on costly cloud infrastructure for certain tasks.
And there's even a theoretical efficiency argument.
There is. A suggestion that SLMs may be fundamentally more efficient due to potentially less sparse parameter utilization compared to the way parameters are often used in giant LLMs, though that's more theoretical.
It certainly sounds like a compelling technical and economic case for specialized SLMs, particularly for agents. But what about the common arguments against them, like the idea that LLMs have a semantic hub that gives them a universal advantage in understanding, or the economy of scale argument for large centralized models, the big brain argument, effectively?
Those are indeed the standard counterarguments, and the NVIDIA paper directly addresses them. For the semantic hub argument, the idea that a huge LLM just gets everything better universally, they contend that advanced agentic systems are explicitly designed to decompose complex problems into simpler subtasks anyway.
So the SLM only needs to understand its small part.
Right. In such scenarios, the broad general understanding of an LLM's semantic hub might be of little utility for that specific subtask. The SLM would be invoked only for these appropriately broken down, simpler operations. Why use a sledgehammer to crack a nut when a precision tool will do it better, faster, and cheaper?
Okay, what about economy of scale? Isn't one big model cheaper to run overall?
Regarding the economy of scale, they acknowledge that setting up and utilizing lots of distributed SLM inference endpoints can be challenging, operationally complex. However, they argue that recent advancements in inference scheduling and large inference system modularization, like NVIDIA Dynamo, offer unprecedented flexibility. This directly counters the traditional view that larger, centralized models are always more cost-effective at scale, especially when you factor in the specialization and adaptation benefits of SLMs.
So the infrastructure is catching up to the idea of using lots of small models.
It seems to be moving in that direction. They admit the jury is still out on the precise long-term economic considerations, but they strongly suggest a shift away from the bigger is always better. Mantra is plausible, even likely, for agentic AI.
So if SLMs offer such clear technical and economic advantages for agentic AI, why aren't they more widely adopted right now? What are the real-world barriers holding back this shift?
That's an excellent question, and the paper identifies a few key practical hurdles. First, there's simply the large amounts of upfront investment into centralized LLM infrastructure.
Inertia.
Exactly. Significant capital has already been poured into building these massive centralized LLM paradigms. This creates inertia and favors tools and workflows built around that existing model. Companies have already made their big bets on LLMs.
Makes sense.
What else? Second, there is a strong historical use of generalist benchmarks in SLM training, design, and evaluation. Much of the SLM development has historically followed the LLM track, focusing on generalist benchmarks like language understanding or generation, rather than benchmarks specifically testing direct agentic utility.
So they're being judged by the wrong metrics.
Arguably, yeah. It might undervalue their specialized capabilities. It's like judging a specialized racing car, primarily on how well it carries groceries. The metrics don't align with the intended purpose.
And the final barrier is just awareness. They're not getting the same spotlight.
Correct. Lack of popular awareness. SLMs often don't receive the same marketing intensity and press attention that LLMs do, despite their potential suitability in many industrial and agentic scenarios.
So these aren't fundamental technical flaws of SLM technology itself.
No, they're framed more as practical challenges of ecosystem inertia, misaligned evaluation, and public perception. The paper posits that as the economic benefits become more apparent and as new tools emerge to manage distributed SLM deployments more easily, these barriers will naturally diminish over time. Though they don't provide a precise timeline for this shift, it's a really fascinating technical debate about where the industry is truly heading in terms of core AI architecture and how it will ultimately impact you, the end user or developer. Hashtag outro buying.
So we've taken a really comprehensive deep dive into OpenAI's GPT-5 today. On one hand, it's undeniably a technologically advanced, unified system. It brings impressive performance gains, particularly in areas like coding and health guidance, all coupled with that pretty aggressive pricing strategy. It's definitely a solid step forward in capability and accessibility.
On the other hand, its launch was met with those mixed user reactions, stemming largely from the architectural changes, the removal of the model picker, the nuances of the internal model routing. And when we zoom out, it operates within this broader context of ongoing technical debates, like that persistent challenge of position bias in large context windows.
Right, the middle of the document problem.
Exactly. And that emerging counter-narrative favoring small language models for specialized agentic tasks. It really represents, I think, a solid step on the performance trend line, but maybe not the revolutionary step change towards AGI that some hype might have suggested.
More evolution than revolution this time.
Precisely. This suggests AI is perhaps on a more traditional technological path where abilities will develop more slowly than products. Product enhancements and cost efficiency seem to be truly driving real-world adoption here, and that's a key takeaway, I think.
And that's what's so fascinating about this entire landscape right now. Considering GPT-5's unified, router-driven architecture, which is designed to seamlessly orchestrate different internal models,
What?
and then contrasting that with the emerging discourse on the efficiency and specialization of SLMs for agentic tasks, what does the future really hold for AI development?
Yeah, it's the big question. Will the industry converge on a single, increasingly powerful generalist model for absolutely all tasks, or are we going to see a more heterogeneous landscape?
Where maybe a unified system like GPT-5 actually acts as an advanced orchestration layer over a diverse ecosystem of specialized cost-efficient models, both large and small, each optimally designed for specific functions.
That's the provocative thought, isn't it? This raises an important question for you, the listener. How might this evolving architectural approach, driven by both technical capability and economic pressures, truly shape the applications and accessibility of AI in the next, say, 18 to 24 months?
Will we see this true modularization of AI, where the most powerful models serve as central decision makers, maybe, delegating granular tasks to a multitude of highly efficient, smaller, specialized models?
Or will the pursuit of the ultimate generalist continue to dominate the developmental efforts and funding? What stands out to you as the most impactful implication of these architectural and economic forces playing out right now?
It really makes you think about the underlying technical trade-offs developers are going to be making constantly and what that ultimately means for how we'll all interact with AI moving forward.
Food for thought.
Definitely. Thank you for joining us on this deep dive into GPT-5. For more insights into the latest AI and ML research papers, remember to visit neuralintel.org. We'll be back soon with another deep dive.